Assalamu alaikum, my dear students. Hoping that you are all fine with the blessings of Almighty Allah. And did not was not able to start the class on time because of severe traffic on the road. But now, Alhamdulillah, we started and we will continue. Okay, now first of all, I'm just going with the homework questions as usual, so that, and I did not send you your homeworks, but they will be sent to you people after 8 or like this. Now, because I just need some rest after the lesson and then I will start sending you homework. Of course, you people have done, sent to me, corrected. I will be sharing it with you people. A girl notices that she shouts into a cave, and she hears an echo. Which property causes the echo? This is so simple question. Of course, answer is C, which is reflection. Because reflection of sound is causing an echo. A fire alarm is not loud enough. This is the fault. And a pitch is too low. So this is also something not prominent. So an engineer adjusts the alarm so that it produces a louder note of a higher pitch. What effect does this have on the amplitude and on the frequency of the sound? So see, adjust the alarm so that it produces a louder note and high pitch. So last time I am writing here, then I will be just going directly. Last class also we did many times. Loudness is directly proportional to amplitude of vibrating body. I'm not writing the complete sentence, but amplitude of vibrating body. So for greater loudness, amplitude should be more. So it means amplitude larger. So C and D is not the answer. And higher pitch. Pitch of sound is directly proportional to frequency of the vibrating body. So if pitch is high, frequency is also high. So greater. Correct answer is A for apple. Correct answer is what? A for apple. And I'm sure you people got it, because after making some adjustment by the engineer with the alarm, its loudness is increased and its pitch is also increased. Loudness is directly proportional to amplitude, whereas pitch is directly proportional to frequency. So if pitch is increased, loudness is more, so it means amplitude and frequency both are increased. So correct answer is A. Then yes, this question now, it is based on echo. A student stands 180 meters in front of a vertical flat cliff. So distance is 180 meters, and bangs together two pieces of wood to make a short loud sound. A timer records the echo of the sound. This much time later, the piece of wood are banged together. Based on this result, what is the speed of sound? So as there is term echo, so speed is equal to 2 times the distance over t. Because sound goes and comes back. So 2 times distance is 180 over t, which is 1.5. As we simplify, answer will be equal to 240 meters per second. So correct answer for 44, it is B. Other question, the next question is 49. Both the amplitude and frequency of a sound wave decrease. Frequency decrease, amplitude decrease. What happens to the sound? Amplitude decrease, sound is louder, no chance A and B. They are out. Sound is quieter, yes, because amplitude is decreased. Pitch is decreased, higher pitch. Frequency decreased, higher pitch, no chance. Lower pitch, yes. Correct answer is D. So very simple. Now this is repeated one way or the other way. So common question. Yes, now this question. A boy stands 150 meters from a wall. Distance is given. He claps, and when he hears the echo, he immediately claps again. He continued for this for some time. Another student has a stopwatch. She starts the watch on the first clap and stops it on the 11th clap. The stopwatch reads 10 seconds. What which value do her measurements give for the speed of sound in air? This is again the case of echo. So V is equal to 2 times D over T, which is 10. So it means over T first. So 2 times 150 divided by 10. So answer is not 10. Not 10. It is equal to 1. So on simplification, answer will be 300 meters per second. So it is C. Question is, why did I use 10 divided by 1? Because echo once. Clap, echo, clap, echo, clap, echo, clap, echo, echo. Clap, echoes 1, 2, 3, 4, 5. Clap, echo, echo, clap, echo. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. See, another student has the stopwatch. He starts the stopwatch on the first clap here. Start. And stops it on the 11th clap. This is the 11th clap. So start and here stops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total time is 10 seconds. So one echo time, clap echo time will be equal to 1 second. So that's why 2 times 150 divided by 1, answer will be 300 meters per second. How much it will be? It will be equal to 300 meters per second. So correct answer is C. Yes, a pulse of sound is produced at the bottom of a boat. As the sound travels through the water and is reflected from a shoal of fish. The sound reaches the boat again after 1.2 seconds. The speed of sound in the water is 1500 meters. So speed of sound is given. How far below the bottom of the boat is the shoal of fish? So speed is equal to 2 times distance over t. This is repeated again and again and again and again. This is reflected. So we need d, distance, cross multiply. 2d is equal to v times t. D will be equal to v times t over 2. Place the values 1500 times 1.2 divided by 2. On simplification, answer will be equal to 900 meters. So correct answer is B. Please read the question. If any one of you is having any query, question, feel free, you people can ask me now. Okay, let's move forward. Yeah, question number 81 now. Sound travels through air as a series of compressions and rarefactions. Which statement correctly compares a compression with a rarefaction? In a compression, the wavelength is longer than a rarefaction, so longer or shorter, no. The distance from one compression to the next compression equal to wavelength, and the distance from one rarefaction to the next rarefaction, that is also a wavelength. So it is neither shorter nor longer than a wavelength. It is same. It is same. So A and B again, no chance. So you can. So you can just kick them out, both of these options. So either answer is C or D. So in a compression, the density of the air is greater than rarefaction. Yes, this is the correct answer. Why? What is the reason behind that? Because in compression, the particles are pushed closer together. So more mass in a smaller volume. So it means density will be more. So correct answer is C. Now the question number is 30. Solve this question now, please. I want everybody's response. Muhammad Hisham, Mahdi Umar, Mahad Rafi, Sareen Fatima. Answer it. What is your answer for this question? And by the way, loudness of the sound does not change. So C and D out. It is either A or B. Let me check your answers now. So yes, Sareen, you are correct, right? Mahdi Umar correct. Ahmad Abdu correct. Maida Khalid correct. Muhammad Abad correct. Muhannad correct. Oh, mashallah, everybody is correct. And one person is sleeping and he said first C, now he is saying A. Please remember, I don't want to write this again and again. Loudness of the wave does not change. Loudness depends on amplitude. If loudness is not changing, it means amplitude is also not changing. It is staying constant. Then, what about the frequency? Pitch varies. It means frequency is varying. So correct answer is B. Muhammad Hisham, wake up. Don't sleep. What is an ultrasound? Sound waves that are so loud they damage the human hearing. How they will damage the human hearing when we cannot hear them? So it's wrong. Sound waves that are too low pitched, wrong. Too quiet for humans. Correct answer is B. Sound waves that are too high pitched for humans to hear, because ultrasounds are the sounds with frequency higher than 20,000 hertz. So it means they will be highly pitched and we humans cannot hear them. So correct answer here is B. Now Muhammad Hisham, mashallah, very good. You are awake. I want everybody to be awake, not sleeping. This question I explained you already last week. Two students are measuring the speed of sound. The students are provided with a starting pistol, a stopwatch, and a long measuring tape. The starting pistol, when fired, produces a loud sound and a puff of smoke at the same instant. Okay, so starting pistol when fired produces a loud sound and a puff of smoke at the same instant. Describe how the student used the apparatus and how they calculate the speed. You may draw a diagram. Now what to do? Here, just you may draw a diagram. It means if you draw the diagram, okay. If you're not drawing the diagram, okay. But I'm just drawing the diagram to make it clear. This is the student, and don't laugh on this diagram, just rough diagram. This student, he is having a pistol, so as he is firing from this pistol, a smoke is produced and a loud sound is produced at the same time. Here's another student standing. He is holding a stopwatch. Now let's suppose this is student A and this is student B. So when the pistol is fired, a loud sound and smoke, a puff of smoke are produced at the same time. So I'm writing the answer now, and if anybody is having a confusion, you will ask me. As the student B sees the smoke, as the student B sees the smoke, he turns on the stopwatch. Student B here. And this is stopwatch. Better to label all the things. He turns on the stopwatch, and on hearing the sound, he turns off the stopwatch. He turns off the stopwatch. He turns off the stopwatch. Sareen, my dear student, apparatus mean the devices, the instrument, the tools which are given to the student. So the student right now, he is having the apparatus. In apparatus, he is having a starting pistol, stopwatch, tape measure. See, starting pistol, stopwatch, and a long tape measure. These are the apparatuses for this student. These are what? These are the apparatuses for this student. Now he turns on the stopwatch, and on hearing the sound, he turns off the stopwatch. Now stopwatch gives, or you can say provide, gives the time taken for sound to travel from student A to B. Measuring tape gives the distance between student A and student B, and then the speed we can calculate by distance over time. This method will give you 4 marks. This method will provide you how many marks? This method will provide you 4 marks. If any one of you is having any problem, feel free, you people can ask me now. Okay, no question. Then next is a device at the bottom of the sea emits a sound wave of frequency this. The speed of the sound in the sea water is this. Calculate the wavelength of the sound in seawater. Calculate the wavelength of sound in seawater. So V is equal to F lambda. This implies that V over F will be equal to lambda for wavelength. This implies that lambda is equal to V, which is 1500 over F, 200. As we simplify, answer will be 7.5 meters. Answer will be what? It will be 7.5 meters. Anybody having any query, any question, feel free, you can ask me. Okay, let's move forward. There was one more question of homework. Yes. Now, state a typical value for the speed of sound in air. Any answer you can write from 300 to 350 meters per second. State the range of the frequencies that can be heard by healthy human ear. Sareen, you can answer it. Muhammad Hisham, you can answer it. Maida, you can answer it. Sareen, Maida and Muhammad Hisham. What is the range of the frequencies that can be heard by healthy human ear? Ruba correct, Mahdi Umar correct, Maida correct, Ahmad Abdu correct, Sareen Fatma correct, Mahad Rafi correct, Muhammad Hisham correct. Very good, mashallah, nice, nice, good. Stay blessed all of you. So answer is, anyway you can write, I am writing it like this, 20 hertz to 20,000 hertz. Then a sound wave has a wavelength of this. This is very important. Lambda is equal to 22 millimeter. It means times 10 raised to power minus 3 meters. 22 millimeters. 22 times 10 raised to power minus 3 meters. Okay. Then use your values for the speed of sound in A to calculate the frequency of the sound wave. So V is equal to F lambda. This implies that F is equal to V over lambda. We have used the speed of sound 300 over lambda, that is 22 times 10 raised to power minus 3. Why minus 3? See here again, wavelength is 22 millimeters. So milli means 10 raised to power minus 3. Please, let's simplify it. 300 divided by 0.022, 13,636. So I can write is, okay, 13,636. So 1.3 times 10 raised to power 1, 2, 3, 4. No, Mahad, no, not at all. They want frequency, not wavelength. So we cannot use it this way. We cannot use it this way. No chance. Okay, what is next? On figure, yeah, there will be range, because this, you know, this value of the answer It can be, speed can be from 300 to 350. So it depends what value you have used, but your answer should be correct according to the value you have used. Okay. So any answer within those values. On figure 6.1, draw dotted lines to represent three different rarefactions. Three different rarefactions. Let's go back to 6.1. See, these are the wavefronts. So this is compression, this is compression, this is compression, this is compression, this is compression. Because I told you, in case of longitudinal waves, compressions are the wavefront. And in case of transverse waves, you can assume crests as the wavefront. They want rarefactions. And I have explained you last class, like if this is compression, then rarefaction, again compression, again rarefaction, and so on. So between, this is compression, this is rarefaction, this is rarefaction, this is compression. See, this is compression, this is compression, 1 and 1. Between two compressions, there is a rarefaction. So they said use the dotted line to represent the rarefactions. This is R. Also R for rarefaction. This is also rarefaction. Please, they told us already that this represents the wavefronts of the sound wave. It means these are the compressions. Vertical lines are the compressions. They want us to draw the rarefactions by using the dotted lines. So rarefactions will be between two compressions. Like trough is between two crests, or crest is between two troughs. So similarly, compressions will be between two rarefactions, and rarefactions will be between two compressions. Okay, let's move forward. State in terms of both molecules and pressure what is meant by rarefaction. We did it already. I will just say, I'm not going to write it. Rarefaction is a place where molecules are pushed further apart and pressure is lower than the surrounding pressure. Bas khalas. Again I'm saying, what is meant by rarefaction? In terms of both molecules and pressure, we will say rarefaction is a region where the molecules are further apart and the pressure is lower than the surroundings. Dear friends, any question you have in your mind, please feel free, you people can ask me now. Yes, Maida.
So there is always a rarefaction between every two compressions?
Yes. Rarefaction is always between two compressions, whereas a compression is always between two rarefactions.
Okay.
Okay, then what's next? Now, on figure 3.1, draw dotted lines. Dotted lines to represent three different rarefactions. Sorry, no come back here. First of all, figure 6.1 represent the wavefronts of the sound. These continuous lines, black vertical lines, they are the compressions. So rarefaction, see this diagram, we know at the top of the page, in the where we studied the sound waves, compression, rarefaction, and so on. It can also be done like this: compression, rarefaction, again compression, again rarefaction. So compression, rarefaction, compression, rarefaction, and so on. So if these continuous lines are compressions, rarefaction, check here now, rarefaction is between two compressions. So one compression here, one here, so rarefaction will be in between. And Maida was asking me, Sareen, I'm sure it is clear, yeah, daughter. And Maida was asking me, sir, rarefaction will be always between two compressions. Yes, you can see here that a rarefaction here is always between two compressions. Here also rarefaction is between two compressions. Even here a rarefaction is between two compressions. But a compression is between two rarefactions here. Compression is between two rarefactions here. Here even compression, that is between two rarefactions. So a compression can never be Two compressions or three compressions can never be side by side. Compression, then rarefaction, compression, then rarefaction, and so on. No, just they told us, so we will follow their pattern. See, straight lines or compressions. So dotted lines, they will be rarefactions, because concentrating the question will help us out to answer it. Yes, you are right, they are simply straight lines. So why we are saying them compression? They told them compression, so we will say that yes, they are compressions. We will say yes, they are what? They are compressions. Okay. So this all homework is done. Now what we are, I'm stopping the recording for a moment, then I will start the new recording for the new lesson for us today. Stay blessed, my dear friends.